So this video is about mental math. So we've talked about this in a few places over the course. And what this chapter is sort of pulls all of the pieces together and lets us think about things. So for the most part, there's some reasons why this is really important. So again, the idea with this is you're presented with some kind of a problem and you sort of want to try to think about it, doing it in your head, hold all those numbers in your head, etc. There's a bunch of reasons for this that I mentioned over the past, so let's just go through them again. So one is just this notion of either teaching a course or working with a student or whatever it is to just be able to sort of see where problems are going, like if somebody's working something out. Can you see that that's actually going to be the right answer without, either having to write down a bunch of steps or, again, pulling out a calculator, which I'll talk about in a bit as well, with that. So that's one thing. It's also really important as an educator to just you've got a good understanding of numbers if you can do a lot of this stuff mentally. You understand the place value system really well. You understand all the operations and the properties. So all the properties that we've been going through, basically we're using that when we do mental math. So we've got all of that. Okay. And let me just make a quick comment about calculators. I mean, one of the things is there was a trend to use calculators sort of in elementary school, I say 25 to 30 years ago type of thing. I think that has phased out again, mainly for the reason that some of the I just illustrated is if you have this reliance on a calculator, you don't have the understanding, the number sense type of thing. And so this is why I think this has been pulled out again. For example, my daughter, she's just starting 6th grade. I think she did a little bit with calculators in the 5th grade, but up until that she did not at all. So, and she has, and I think I'm pretty impressed. She's got a pretty good sort of mental math capabilities as well. So anyway, this is something to instill. So this is something you sort of as an educator should really think about and try to hone. Okay. So the next thing I want to talk about is let's talk about writing mental math. So I've got a problem here. Okay. So we've done this before, and let me show you the way that I'm going to approach this. So the thing about this is, so a problem like this, okay, mental math, what I would say is, can you try to figure out how to do this again in your head, right? And so I'm thinking about this. I think I've got 62 in my head as the answer. So let's take a look on how I would arrive at that. Okay. Now, here's the way I would look at this. Now, this is one of these things. How is it that you show your work in mental math? It's kind of a conundrum, right? Because the idea is to just write the answer down. But it's also really important to think about what your thinking is. And so there's going to be two things about mental math. So one is I'm going to really want you to think about, like, take a problem, approach it, how is it that I actually do it in my head? And then secondly, so there's going to be some written homework, and there's also going to be some web work and some group work. When I ask you to write it down, so not on web work, but the other cases, I want you to actually write these steps down. Okay, so this is now, what we're going to do is we're going to use the any order property, which is a combination of the commutative and associative properties of addition. So I'm going to grab these two numbers. Let's write the 13 first. I'm going to grab these two next, and I'm left with 14. So I think what I said was wrong. Earlier I made an error, but that's okay, we'll fix that. So that's 30, that's 20, that's 14, that should be 64. I think I said 62. So I grabbed that 12 twice. Okay, so this is how to show it. And then when we do some other things, we'll talk about some compensation. You can also show a little bit more about how you're doing things. But right, so all I've done is I've grouped, right? And I'm grouping this because those are often called compatible numbers. Those go together nicely to give me a multiple of 10. The same thing with that. And then 30, 20 plus 10 is 60 plus 4 is that, right? Okay. Now, let's say I have the same problem and you write the following down. So I'm going to write 13 plus 17, which is 30, and then I'm going to add 8 and 12, and I'm going to say 8 plus 12 is 20, and then I still need to add the 14, right? And so I got 30 plus 20 plus 14 equals 64. Okay, and I might have been standing in front of that a little bit more. All right, so what I'm doing, like, you can kind of see like where these numbers are coming from, and I'm getting some intermediate steps. But this, I'm just gonna, like, if you wrote this down in your notes, I'm gonna just like put a big X through it. Here's why. Okay. Equal sign means equal. So you had a homework problem about this. And equal sign means equals. This is 30 on this side, but this is, that's 20 and that's 30. So this side is 50, that side is 30. That is not an equal sign, right? Those things are not equal to each other. Same thing with this. That is 20. This side is 34. Those are not equal to each other. This one was okay, right? But this is really, this illustrates, and then the rest of the stuff, the other videos that we'll do after this, are going to illustrate how I want to show it. Okay, I'm starting with the original problem, okay? And then I link by equal signs each step. And each step has to be equal to the previous step. So this, again, was just rearranging, right? And then I started to actually do the calculations until I got to the very end. Right? This is a series of a bunch of intermediate steps interwoven with things, okay? Now let me show you something that is often done, and it's okay. I prefer this, and I'm going to try to push you into this. I can write that. I can write that. And then I can say 30 plus 20 plus 14, 64. This is okay. I prefer this. And the reason why this is okay is I've actually, each of those are actually equal signs. Okay, so, got that. All right. Yeah, I'm going to do a little bit more in this video. Let's see. Okay, so let's do some examples. And the first one is a lot like the first that we just did, and this is often called a rearranging thing. So let's look at a different one here. I'm going to do 2 times 57 times 5. Okay, so that is my problem. Okay. Now remember, both addition and multiplication have the same any order properties. So what I would do with this is I'm going to rearrange make that a 10 times 57 to get 570. Make sense? Okay. And again, I'm starting with the problem and I'm linking by equal signs across. Okay. Now this one isn't too bad, but let me show you a good way to think about how to do this. So how would I do this? Well, 102 times 8, what would I actually do? I'm going to do 100 times 8 and then 2 times 8. So I'm really going to blow this first number up like that. And then this is 100 times 8 plus 2 times 8. All right? And you don't need to write this, but let me just remind you, this is the distributive property. Right, that's the only one that is both addition and multiplication. And then I got 800 plus 16 is 816. Okay. So, and this is actually one of these that I think that you could think about in the column algorithm. So I mean like this, 8, 102, right? That's pretty straightforward. This is completely identical to that. Is the way you kind of do that. But this is a good way to show thinking. (96) divided by 3. Okay. Now, how are we going to do this problem? So, a couple things you might want to think about is, well, I can divide 90 by 3 and 60 by 3. Sorry, and 6 by 3. Okay. So this is also distributive. So 90 by 3, it's pretty thorough, is 30, and 6 divided by 3 is 2. I just get 32. So that's often what's called rearranging. All right. And then let me do one more kind of class called compatible numbers. Okay, the first example that I did in this video was an example of compatible numbers, but here's some others. Let's do 4 times 8 times 34. 8 times 3 times 8 times 25. Okay. So this is a little bit like the last one, which we did with some rearranging. This is going to be involved in this. So I have to look at this. I've got 4 numbers there, and again, I can do any order. On this, I want to pull out things that are compatible, things that sort of the result, in this case multiplication, gives me a nice number to deal with, right? And I would look at this, and there's the 4 times 25. So I'm going to write that 4 times 25, and then I've got 3 times 8, right? And so I get 100 times 24 is 2400. And let's do another one that was similar to the very first one that I have. So 17 and 28, and 43 and 22 and 19. Okay. All right, so this I think is a great example, because before you would just say, wow, I have 5 numbers. How am I going to try to add those in my head, right? And the thing about it is, if you try to do this in your head and you just go left to right, you know, you've got that, not too bad to do. 7 and 8 is 15, and then 2 is 30, so it's like 45. And then I have to keep that in my head and add 43 to it, and then I have to keep that in my head and do 22, and then finally 19. So if you just keep tacking on more numbers, you've really got 4 additions in there. Right? So what I'm going to do is I'm going to look at and just go, oh, well, what things sort of go together nicely? And so all I'm looking at is the ones digits. So I got a 7 and an 8 and a 3 and a 2 and a 9. And this is where like tens combinations that we talked about before are very important. So I got 7 and 3 is a tens combination, and 8 and 2. So I notice 17 and 43 go together quite nicely. And 28 and 22 go together nicely. And I'm left with 19, right? So I add those together, I get 60, and that's 50, and 19. So that's 110, and 19 is 129. So there's another example with some compatible numbers. And you really should be able to now do this mentally. So I should be able to go, all right, so I see 17 and 43. That's 60. Okay, there's 50. So together that's 110, and 19 is 129. Right? Sometimes just talking through that is a good way to go through and do that at all. Okay, so that's the first little part of the mental math chapter. And I've got another video following.